Hi, welcome to my YouTube channel, and in this video, we'll be solving warm-up 1 of the MathCOUNTS practice handbook, and I'll put a link to the entire handbook in the description, so you can go check out that and solve this warm-up and other warm-ups if you want. So let's get into it. So the first question is, what is the result when 128,000 is subtracted from 1 million? So so basically 1 million is the big number. And we're subtracting 128,000 from it. And we're not allowed to so let's assume that we can't use a calculator on this problem. In the actual MathCOUNTS competition, we are allowed a calculator on the chapter version, but we are not allowed a calculator on the chapter version, but are allowed a calculator on the target. And let's assume that that this is without a calculator, and because if it was, this would be very easy. So 1 million, we can write that out with 6 zeros, and then 128,000. So we can just subtract these 3 zeros because they cancel out each other. So this turns into 1,000 minus 128. Okay, I'm just making sure that you guys can see this. And we can just do the regular subtraction. We would just distribute this. It would become a 9. This would become a 9. This would become a 10. And remember that I'm doing it kind of fast. And I'm not doing it like the proper step by step. So what I did is basically I took this as a 0. This would become the hundredths place of the big number would become a 10, and then it would become a 9, and then it would just go and follow the chain. Yeah. So it would be 10 minus this 0 becomes a 10, and 10 minus 8 is 2. So we write a 2, and then this is a 9, and then we would do 9 minus 2 is 7, and then 9 minus 1 is 8. So then the result would be 872, 1, 2, 3, and then 3 zeros, because we have to add this back. So 872,000 is the first answer. Okay, so the second question is, how many unit cubes are required to create a larger unit cube with an edge length of 3 units? So basically, we want to create a cube that has basically an edge of 3 units. And so basically it should have a height of 3 units, it should have a length of 3 units, and it should have a width of 3 units. So we can expand this, and I'll try to use my drawing skills here. And so the basic concept is that we have a 3 by 3 by 3, and if you're familiar with a Rubik's cube, it has a unit. We can just say each cube is basically a cube in this, and it's a 3 by 3 by 3, or if you multiply that, that's 3 cubed, which is 27. So we would need 27 cubes to make a larger cube with an edge of length of 3 units. Okay, so the third problem. What is the remainder when the sum of the smallest and second smallest prime numbers is divided by the third smallest prime number? So the smallest prime numbers are numbers that whose factors are only 1 and itself. So the smallest prime number is 2, because 1 isn't prime number because 1 is the only factor of it. So 2, 3, and 4 is it because it has a factor of 2 as well, so that's 3 factors. So it's called composite. 2, 3, and 5. These are the first, second, and third smallest prime numbers. And the question is asking what is the remainder when the sum of the smallest and second smallest, so 2 and 3. So the sum of 2 and 3 is 5. And what is the remainder when the sum of the smallest and second smallest prime numbers is divided by the third smallest? And this is the third smallest, so 5 over 5. And that is equal to 1. So it has no remainder, actually. So we would say 0. Okay, so let's go to the fourth problem. Okay, so the fourth problem says in parallelogram WXYZ shown here, the measure of angle W is 80 degrees. What is the degree measure of angle X? So in all parallelograms in squares and rectangles or any four-sided figure, the sum of all the interior angles is always 360. And this is a parallelogram. So basically the opposite angles will have the same angle measure. So that means angle W and angle Y will have a measure of 80, and let's just say that angle X and angle Z will have an angle measure of Y. So basically we'll go one by one. So 80 plus 80, which is the measure of angle W and Y, plus Y plus Y, which is the measure of angles X and Z, is equal to 360. And we can simplify this by saying 160 plus 2Y is equal to 360. And then subtract 160 on both sides to isolate our variable. So 2y is equal to 300, and y is equal to 150 once we divide by 2. So that means the measure of angle x is 150. Let's go to our fifth problem. What is the value of 6 divided by 2 times 3 plus 8 divided by 4 times 2? So this is testing your knowledge on PEMDAS, or parentheses, exponents, division, multiplication, addition, subtraction. Actually, no, I got the order wrong. PEMDAS. And to be honest, whether you do multiplication first or division first, it doesn't matter. As long as you do them before addition and subtraction, it matters. So basically, you can group these two. So yeah. So parentheses, exponents, multiplication, division, addition, subtraction. And so with that in thought, we can do our the problem. And we always, when I said multiplication division, it always means we want to go from left to right and do them in order. So basically we want to do the multiplication and division from left to right. So let's do that. And we see that there are no exponents or parentheses. So we can do 6 divided by 2, because that's the first thing from the left, which is 3, times 3, which is 9, plus 8, and we're not going to do the addition and subtraction yet because we haven't finished with our multiplication and division from left to right. It's plus 8 divided by 4 times 2, and 8 divided by 4 is 2, times 2 is 4. So we're left with 9 plus 4, which is 13. Okay, let's go to our next problem. If Yasuko randomly selects a single-digit positive integer, what is the probability that it is not prime? Okay, so we have this person here that's selecting a single-digit positive integer. So that can be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9, and no 10. And we have to also remember that 0 isn't positive. It's not positive or negative, so we can't include it in our list. So basically, the problem is also saying express your answer as a common fraction. So that means it wants us to do a fraction, and we can see that there are a total of 9 options here of him to select from, him or her. I'm not sure. But we can do so. The probability that it is not prime, and we learned earlier in problem number 3 that a prime number is a number that has factors of only 1 and itself, and prime numbers in this set from 1 through 9 are 2, 3, 5, and 7, and those are the only 4. So we have a probability of 4 over 9 Oh, actually, wait. See, this is why it's important to read the problem. So it's asking what is the probability that it is not prime, and so the probability that it is prime is 4/9. However, the probability that it is not prime is 5/9. Okay. Okay. To the next problem. What is the value of 0.001 times 1/10 times 10 to the power 5? Okay, so what we want to do here is convert them into the same form. And I chose decimal. So we can do 001 times 0.1 times 100,000, which is 10 to the power 5. Yeah. And basically, what we should do first is 0.001 times 0.1. And what we could, instead of doing like the calculation like manually, we should just shift the decimal place one place to the right. So that would become let's say 0.0001. And then this times 10,000, and that would shift the decimal place 5 digits to the right. So it would be 1, 2, 3, 4, 4, 5, and that would be 10. So that would make the answer 10. Yeah. And to the next problem. What is the value of 3 times in parentheses 4x plus 5y minus 2 times in parentheses 7x minus 3y when x is equal to negative 2, y is equal to 3? So let's substitute the variables in each parentheses. So 3 times 4 times negative 2 plus 5 times 3 minus 2 times 7 times negative 2 minus 3 times 3. And these problems, like, they take practice and like you have to see it and then you can practice. So what we want to do what's in the parentheses first, and that's -8. Like, we want to do the parentheses first because of the PEMDAS rule that we learned earlier. So -8 plus 15, and then we want to add the 3, minus 2 times -14 minus 9. And I'm just breaking it up so it's easier to understand. So 3 times, and then -8 plus 15 is 7. And then this, and then so this minus minus 2 times -14 minus 9, and this is negative 23. Yeah. I just blinked out there. Okay, so that's 3 times 7 is 21 minus 2 times -20 minus. So this is actually a -2. So we want, when we apply the 2 to -23, you want to take the negative sign. So it's -2 times -23, and the negative times the negative is positive. So it's going to be 21 plus 2 times 23, which is 46. And we can add these two up and we would get 67. So 67 is our answer. Yeah, I'm just going to making sure that we can see the page. Okay, yeah. And then if 4, so let's go to the next problem. If 4/18 is equal to A/27, what is the value of A? And when we are dealing with ratios, the way to do it is multiply the top left to the bottom right and the bottom left to the top right. So it would be 4 times 27 is equal to 18 times A. 4 times 27 is 108. 108 is equal to 18A, and then we should just divide by 18. And that makes A equal to 6. Yeah. To the last, actually, problem. So, Daifuku is a snack made from glutinous rice flour and sweetened red bean based. If a recipe for Daifuku requires 3 cups of sugar, I'll have to look and how to pronounce that word. So 3 cups of sugar. How many cups of sugar are needed to make 64 Daifuku? So basically, this is a ratio problem, just like we did in the previous question. So 24 Daifuku needs 3 cups of sugar. So this is the D and this is the sugar. And then we need to find out how many cups of sugar are needed to make 64. So this is our thing. And as we learned before, we just have to multiply, and then we can put some variable here. Multiply this. So 64 times 3 is equal to 192. 192 is equal to 24x. Then you divide it by 24, and that gives you x equals to 8. In this case, that's 64 cups. 8 cups of sugar I need to make 64 Daifuku. And another thing I just want to point out when solving these ratios is that so we can learn that there's also like an input output thing with these ratios, and basically 3 times 8 would give you 24. So x times 8 should give you 64, and we know that 8 times 8 is 64. So that's another way to solve these ratios if you don't want to do the this method, which is commonly referred to as the butterfly method, in case you were wondering. So that takes us to the end of our warm-up. And this is a warm-up 1 out of 11. And I'll hopefully be making videos on solutions for all 11 warm-ups. As we progress, the questions will get much harder until we get to warm-up 11. So make sure to subscribe and like this video to stay in touch and watch those the solution videos. Also, if you comment down below your favorite problem on these, and maybe if you have another way of solving them. Thanks for watching.